Hello, we're going to go over math review for Essentials Pharmacology today. Um, we're going to talk firstly about conversions, okay? The most frequently used conversions are shown below. It's suggested that you memorize these, okay? 1 kilogram equals 1,000 grams. 1 kilogram equals 2.2 pounds. 1 liter equals 1,000 milliliters. 1 gram equals 1,000 milligrams. 1 milligram equals 1,000 micrograms. 1 ounce equals 30 mLs. 1 teaspoon equals 5 mLs. And 1 tablespoon is equivalent to 15 mLs. One helpful way to remember this is to remember that a kilogram is greater than a gram, which is greater than a milligram, which is greater than a microgram. So as you're converting those numbers, you can kind of figure out which way to move your decimal point if you want your number to get bigger or smaller. Temperature conversions. Converting Fahrenheit to centigrade, you're going to take your Fahrenheit minus 32 and then divide by 1.8, and that'll give you your Celsius. Now, if you have Celsius and you need to convert it to Fahrenheit, you would take your Celsius, multiply it by 1.8, then add 32, and that will give you your degrees in Fahrenheit. We're going to go over an overview of rounding. Okay, decimal numbers are often rounded when pharmacology calculations are done. For example, if your answer to an intravenous flow rate is 67.8 drops per minute, you would have to round that number off to the nearest whole number, because if you think about it clinically, you cannot count parts of a drop. Okay, it's either a whole drop or no drop. It is not a half of a drop or a quarter of a drop. So drops always need to be rounded to the nearest whole. Some examples here, if you do a calculation and it comes out to 23.8, you round that up to 24. If it comes to 65.4, you round it down to 65. Use the 0.5 and above to round up, or 0.4 and below to round down. Similarly, if you have to round a number off that's 23.54 to the nearest tenths place, you would look at the number in the hundredths place. And if that number is 5 or more, you would round that number up in the tenths place. But if the number is less than 5, you leave the number in the tenths place as it is. Here are some decimal numbers rounded to the nearest tenth. So 23.84 is rounded to 23.8. 67.47 is rounded to 67.5. Here are some decimal numbers rounded off to the nearest hundredth. So 23.847 would be rounded to the nearest hundredth at 23.85. 67.472 is rounded to 67.47. Remember, don't round when drawing up a medication in a syringe. If the answer is 2.6 mLs, then that is the answer. Rounding would be incorrect, giving more or less than ordered. Don't round tablets. Usually they are whole or half of a tab. If it's anything other than that, check your math or check with the pharmacy. Don't round mLs when giving liquids. Rounding would give the patient more or less of the medication ordered. So if you're pouring it into a cup or you're drawing it up in a syringe, do not round. Tips for success. Read the whole question. If you have a paper exam, cross out any unnecessary information. Before solving problems, check to be certain that the order and the supply are in the same weight of measure. If they are not the same weight of measure, you must convert one or the other to its equivalent. The simple formula method. Now, this is the method that I use when doing um, medical calculations. This is going to work most of the time, almost all the time. You take what your doctor ordered or what you desire over what you actually have on hand, or like when you go to the med room, this is what the Omnicell gives you, times what it comes in. So if it gives you a vial that has, 10 milligrams per ml, then it's going to be, and your desired order is 20 milligrams, you're going to put 20 over 10 times 1 because every 10 in 1 mLs. Plug the numbers in and solve. Remember, conversions are completed before you place them in the equation. Your top and bottom number have to be of the same measurements, either both milligrams to milligrams, but you can't have grams on top and milligrams on the bottom. Dimensional analysis, same thing. You use your desired over, or your supply over have, and then your desired times X. Plug in the numbers and solve. Remember, conversions are completed before you place them in the equation. They have to be the same measurement. There's a formula method, a proportion method, and dimensional analysis, different ways that you have to do different equations. All of these will give you the same answer. Pick the one that works best for you. For me, I use desired over have times supply. That is the easiest. It's the simple method, and plugging those numbers in is going to give you the right answer 99% of the time. There's a sample question here. If the physician orders digoxin 125 micrograms every day, the available dose in the medication cart is 0.25 milligrams per tablet. How many tablets does the nurse administer to the patient? So for this answer, you have to convert first. Micrograms to milligrams or milligrams to micrograms. I typically choose to make milligrams to micrograms because that makes the most sense to me because the ordered dose is in milligrams. Now, if the ordered, or in micrograms, if the ordered dose was in milligrams, I would switch it the other way. So 0.25 milligrams is equal to 250 micrograms per tablet. The desired order is 125 micrograms. Conversions are done prior to arranging them into your equation. So for me, I would use the desired over have times quantity. So the doctor's order, or what I desire to have, is 125 micrograms. What I have on hand is 250 micrograms per tablet, so times 1. And that should equal 0.5 tabs, which does not need to be rounded because you can give half of a tablet. Anytime you have weight-based equations are based off of the kilograms a person weighs. So if you see something in pounds, you need to convert it right away. 2.2 pounds equals 1 kilogram. So if you take whatever you have in pounds, you're going to divide that by 2.2 to get your kilograms. If you do not convert, your answer will be incorrect. If the doctor orders 2 milligrams per kilogram of Lovenox daily, the patient weighs 155 pounds. The first thing you should do is convert that to kilograms. You are supplied with a Lovenox syringe that reads 40 milligrams in every 0.4 mLs. How many mLs do you administer to your patient? So what you desire, what the doctor orders, is 2 milligrams per kilogram. You have to figure out what your kilograms are first so that you can do 2 milligrams times the amount of kilograms. Reconstitution is when you're dispensed a powdered medication and have to add a certain amount of liquid to make a specific concentration. For example, when adding a powdered 40 milligram vial of Protonix to a 10 ml syringe of normal saline, You are reconstituting the medication into a liquid form that you can later divide into equal parts. You can then divide the 10 mLs into equal parts depending on your doctor's order. So if the doctor orders 20 milligrams of Protonix to be given, how many mLs do you administer? Safe dose ranges. Safe doses can be found in a drug book, along with therapeutic dose ranges. If a child weighs 50.6 pounds and has an order for gentamicin, 50 milligrams, IV piggyback, every 8 hours, the recommended dosage for a child is 6 to 7.5 milligrams per kilogram per day, divided every 8 hours. Is this dosage ordered safe? Some of these are equations you're going to have to work out on paper, and you can pause the video at any time. Yes, the dosage is safe. Okay, so we convert the pounds to kilograms. Just 50.6 pounds equals 23 kilograms. Now to determine if the dose is in the safe range. Okay, so your safe range is 6 milligrams or 7.5 milligrams is your maximum dose. So 6 times 23, because that's your kilograms, equals 138 milligrams per day. Now 7.5 times 23 is 172.5 milligrams per day. Now, because we're giving this every 8 hours, you want to divide by 3 now. It's 8 goes into 24 hours 3 times. So now you're going to divide this dose by 3. So the first one's going to give you 46 milligrams per dose, and the highest dose per day is going to give you 57.5 milligrams per dose. The dose that you've been ordered is 50.6. Does it fall between 46 and 57.5? Yes, it does. And that means it is a safe dose to give. Now, talking about drip factors. A micro drip is 60 GTTs per ml, so 60 drops. But a macro drip, you really need to check the packaging on this. The packaging will tell you on the tubing what drip size that chamber is, whether it's 10 drips per ml, 15 drips per ml, and sometimes it could even be 20 drips per ml. To calculate the IV drip rates, this information has to be known, and it'll always be given to you because it will be on your packaging. In order to calculate drip rates, the best way to remember to do this is volume over time times drop factor. Okay, so the number of milliliters to infuse is your volume. So if the doctor orders to be infused 120 mLs of D5W over 60 minutes with a drop factor of 10, the calculation should be 120 mLs over the number of minutes, which is 60, and then multiply that by 10 because you already have it. The greatest thing about these calculations is you have all of the information available to you. The only time you have to convert is if the top number is not in mLs. If it's in liters, it needs to be converted. If the bottom number is in hours, it needs to be converted to minutes. So it has to be ml over minutes times your drop factor. So make sure if something says, over 2 hours that you're converting that to 120 minutes as your bottom number. Now calculating IV drips for an infusion pump. Infusion pumps' basic settings are calculated in millimeters or milliliters per hour. The calculation looks like the total number of milliliters ordered over the number of hours to run will equal your ml per hour. So in this example, the order is to infuse 120 mLs of D5W over 60 minutes with a drop factor of 10. Notice that 60 minutes was changed to 1 hour, okay? So when you're talking about an infusion pump, we want to have that mLs over hours, okay? That's the only time, so this is not a drip factor. This is for the infusion pump, the IVAC, the Baxter pump, the iMed controller. They have all different names. So here's a practice question. The doctor orders 12 units per kilogram per hour of heparin infusion. The patient weighs 200 pounds. You are supplied with 30,000 units per 500 mLs. What is the ml per hour rate? So first thing you need to do is convert that 200 pounds to kilograms. Then you're going to multiply that by 12. Then you're going to put that number over 30,000 and multiply it by 500. What is the ml per hour rate? If you put all of those in place, you should get 18.18 mLs per hour.